Hi, welcome back. My name is Rich Roberts. I'm a medical doctor and a doctor of biophysics. I was educated and trained at Penn and Harvard, respectively. I was a CEO in the pharmaceutical industry for 24 years, and this is my 6th video on coronavirus. There's a lot to tell you, so I'm going to end up breaking it up into pieces, but you can just continue from one piece to the other. What I want to talk about today are regarding the coronavirus in the United States, what we need, why we can't have it, what we have to do, and what the dangers are. Along the way, I hope to impart some information to you about corporate management, business, economics, and politics along the way. So here we go. To beat this coronavirus, what we need is everyone to stay inside across the entire world for at least 2 months. And we also need everyone in the United States to get antibody tested. The antibody test is needed because if we could get everyone tested to see if they have the antibodies to coronavirus, it would give us a very good idea of how extensive the infection has been thus far. So for example, if we find that only 2% of the United States has been infected by this virus so far, then that lets us know that if we've lost 106,000 people so far, then we could be looking at 50 times that, or 5 million people being lost. Alternatively, if we find out that 99% of the people have already been infected by coronavirus, then we could say, forget the masks. Unless you're an absolutely well-known to be high-risk individual, you'll just stay quarantined, but everyone else just tear open. This is going to come to the first life lesson in this video. There's a group of doctors in Stanford, California, who came out when there were about 40,000 deaths and said they tested about 330 people for the antibodies. Almost every single person had anti-coronavirus antibodies. And that says to them, everyone has been infected. Therefore, this is no worse than the flu. There have been about 40,000 deaths so far at that point. It might be 50,000, but the fact is, on a normal flu season, we're not talking about the pandemic of 1918. You're looking at somewhere between 15,000 to 69,000 people dying in the United States in a year. And the majority of those deaths happen in the elderly and people who are very sick. So this gets us to the first life lesson, and that is, I use this, by the way, when I was running our corporation. If you get data that doesn't seem to make sense, just common sense with what you see going around, you need to think, is there something wrong with that data? You should always question data anyway. I mean, I've had people throughout my life quote me, this fact, that fact. How could you think this is true when this is true? And it turns out the facts they're quoting are not facts at all. They're just wrong. So when these doctors in Stanford went on the internet and they got 5 million hits because everybody wants to believe this is just the flu, when they went on and they said they tested 330 people, plus or minus, you'll learn as a CEO, you can just conceptually understand something. And if you're off by 5 or 10%, it doesn't change the takeaway message. So they tested about 330 people. Every single one of them, almost every one of them has been infected with coronavirus. That means that everyone's been infected, and the idea that we have 40,000 deaths at this point, that will be the end of it. Now, if you just use your brain a little, you say, okay, I've lived through a lot of flu seasons. I've never seen a flu season where they have refrigerated tractor trailers attached to hospitals to hold all the dead bodies. You would say, I've never seen a flu season where so many doctors and nurses have died treating people on the front lines. As a matter of fact, in our Orthodox Jewish community, I know 3 medical doctors who have died from coronavirus already, and there's others that have been very, very sick, and one, thank God, looks like he's going to make it, but it was very, very close. So when people tell you things in life that just don't seem to jive at all with reality, you need to just be very careful about believing what they say. Now, I'll tell you something very interesting. When you get to the absolute most advanced levels of physics, it becomes what you call counterintuitive. in physics, they say this is counterintuitive. In other words, things actually function or seem to function on an atomic level in ways that our universe doesn't seem to function in the world that we live in, even though our world that we live in is made of elements from that atomic world. That's known as counterintuitive. But okay, whether that's right or that's wrong, we have the equations, that's another story. But in your life, when people tell you something and it just doesn't make sense, here, you're going to invest with me and we're going to buy this store and we're going to start a business there together. Okay, great. So give me $40,000 and I'll go buy this store. Whoa, wait a second. I'll send the money to the lawyer, and the lawyer is the one who will release the money when we actually do the purchase. No, just put it into my account. You could trust me. Whoa, wait a second. That doesn't make sense. Why won't you let me put it in the lawyer's account? It doesn't make sense. When things don't make sense, you need to question them. So as much as anti-vaxxer types or people who want to deny the coronavirus will try to latch on to such an idea, we all know people are, right now 106,000 people have died. And we know, therefore, that the data from that California study was flawed. Now, in medical science, one of the things that we call a peer review, which means that when a medical doctor or scientist does research and writes it up as a paper, that paper is sent before a board of other doctors who try to challenge it. And one of the things the doctors will challenge is, did you, in the population that you did this study, do you have skewed results? For example, let's say they do a study, they say, well, in Japan, there were very few heart attacks before we introduced our Western style of food and they started eating lots of meat. Now in Japan, there are tons of heart attacks. So clearly meat caused the heart attacks. Now, that may be true or might not be true. Let me ask you, you had 1,000 people who didn't eat meat and 1,000 people who did eat meat. And you saw the meat eaters are the ones who mostly got the heart attacks. Now, did you control in your study for smoking? Maybe 99% of the people who were the meat eaters also smoked. And maybe only 1% of the non-meat eaters smoked. Did you control for age? Did you control for exercise? Did you control for obesity? So these are the questions that happen when information in medical science is peer reviewed. You have other doctors that go in that know the area scientifically and they say, looks like a very solid result, or it's an interesting result. We need to reproduce it, but you're going to have to control for this factor or that factor. This goes across virtually every single medical study in medical science that you will ever see. So for the Stanford doctors, who are these 300-some people that they tested? Well, they happened to be standing in a mall during the outbreak, during this epidemic, and taking blood samples of people walking in the mall. Well, these might be the people that are the most viable. These might be people that already had been sick, because clearly, actually, almost all of them did have antibodies. So all of them had already been infected. And now they felt it was safe for them because they've already been infected, they got over it. Now they're out and walking around. And you have what's called a very skewed population. So what we really need is we need to test everybody for antibodies. The trouble is we can't do it because it's extremely resource intensive. I saw the Prime Minister of Great Britain saying about a week ago that they're really gearing up and they're going to be able to test about 3 million antibody tests within 3 months. So I saw the Prime Minister of Great Britain said that there's a certain large number of antibody tests they're going to be able to test the public within the next 3 months. But if you look up the population of Great Britain and the number of tests he's talking about, he's saying that within 3 months he'll be able to test only 10% of the population. It's really not going to help much at all. Now in New York State and New York City during the pandemic, which is among the most hard hit of all the cities in the United States and states in the United States, they did antibody tests sampling around the population. Hopefully they did very good control to make sure they were getting a good, proper, representative sampling. And what they found is somewhere between, from New York City to the state, somewhere around 15% city to 5% statewide have been infected already because they have antibodies to coronavirus. Now, this is very bad news. Assuming, this is an assumption, assuming that people who get infected develop antibodies, this means that you're looking at somewhere around 7 to 10 times the number of people who died in New York State could still die in New York State if the virus is allowed to spread everywhere. And across the rest of the country, meaning from the coast inward or from the Northeast also southward, there hasn't been so much exposure and so many infections yet. So that means that the population in general is really exposed potentially to several million people dying from this virus. Alternatively, there might also be the case instead that maybe the virus has swept through nursing homes where there's the most exposed population, the very elderly population, and the number of people left to get infected that would actually die from the virus is much less. We don't know. We just don't have those numbers yet. But that's why it would be great to test everybody with the antibody test. It's not going to happen, but that's why it would be great to do it. I want to make two other points about the antibody test. One is the antibody tests are not 100% accurate. What's important to know with this is, let's say it's 99, well, there's something called false positive and false negative. I'm not going to go into that right now, but let's say the test is 99% accurate, meaning 99% of the time, if the test tells someone that they have antibodies, that means that they really had the disease, they had this infection, and they fought it off, and they should be protected. Not 100% guaranteed, but they should be protected. The trouble is, 1% of those people are going to be told that they have antibodies, and they don't, and they really don't. The test was a false positive. Out of 1 million people, 1% is 10,000 people. That means you could have 1 million potentially exposed people who are told, go ahead, no problem, you have antibodies, and yet out of them, 10,000 have never been exposed to this virus, and 10,000 could die. That's another problem with the antibody test. There are other issues as to what the level of antibodies need to be, but generally, when someone has had an infection, assuming that the virus doesn't change each year, there's something called antigenic drift. It's not important to know, but like the flu does, you have to get a new flu shot each year because something about the way it looks on a molecular level changes. So far, the coronavirus has not been doing that. It's been having some changes called mutagenic changes, but none that have occurred in the thing that the vaccines or the antibodies would go after. So that's good news. But there will be some cases where the antibody levels are not sufficient to protect the person. In general, if I had antibodies, I would be thrilled at that point. There's a personal note. I did get antibody tested about 2 weeks ago, and I'm negative. I do not have antibodies, which is not surprising because I've been in pretty strict quarantine. Another thing I want to mention, and this is not, I don't think this is necessarily consistent with medical science, the medical science thinking. There are a lot of people who've been exposed to this virus, clearly exposed, highly exposed, living with someone who has there are people who clearly have had the virus, and they've tested negative for the antibodies afterwards. Now, for the people that have clearly been sick with coronavirus, and then they might have been diagnosed positive by the nasal swab, which looks for the virus itself, not the antibodies that your body makes to attack the virus. It looks for the virus itself. They tested and they were found to have the virus in their nasal passages. So assuming the test was accurate, not a false positive, they really had the virus, and some of them got sick. I know several cases where they don't have antibodies. They've been tested repeatedly. They don't have antibodies. Now, that is a standard part of medicine where we know certain people have very strong what's called innate immunity, which are the immune cells that are already, in a sense, going around in your body and ready to attack new things. And their innate immunity is so good that it was able to kill the coronavirus before it could take hold. And then you have to develop antibodies against it and memory cells and a whole lot of other stuff. By traditional medical thinking, it's likely that those people have an innate immunity. But there's something else that I suspect is going on. When you see so many children for the most part just don't get this virus. They don't get it. And what it looks to me like this is not the immune system, and I don't have any proof of this. This is not fact, but it looks to me like there is a chemical nature, an intrinsic chemistry of certain people that the virus just won't grow on. For example, if I tell you I threw a match onto a pile of leaves, would it catch fire? Well, it depends. If it had just rained, a massive rain, and those leaves had just been taken off a tree, there were green leaves, and there's water all over them, the match would just go out. Alternatively, if those leaves were totally dry, inside and out, it would catch like a bonfire. It looks to me, and we know, the whole idea of hydroxychloroquine and zinc is that we know in the laboratory setting, in cell cultures, that where there's a lot of zinc inside cells, the coronavirus will not grow. It could be, and we also, by the way, we know that zinc levels decrease from childhood until elderly, which does correlate with the fact that the older people get, the more likely they are to get ill or to die from coronavirus. This is not proof. I'll say it two more times. This is not proof. This is not proof. But it does appear to me, and by the way, it might not be zinc. Maybe it's some other chemical. I don't know. Something that's lost from childhood to the senior years of life. But it does look to me like the virus just doesn't take in children. Now, what I'm saying, you're going to say, oh, I heard about a few children have died from an inflammatory disease called Kawasaki disease. Yes, that's right. If I'm talking about, if what I'm saying applies to 99.9% of the children, that's what the observation seems to be. And I just suspect that it's not an immune function. I suspect it's a chemical status. Whether that chemical is zinc or something else, I don't know.